Assalamualaikum and hello. Now I will present our mini project is automated maritime vessel detection and classification using HOG-SVM and multivariate architecture of R-HOG, C-HOG and P-HOG. Before that, I would like introduce our roadmap that is Muhammad Najib bin Qasim Misbah, matric number 190102097, program RK20 Computer Engineering, and my name is Muhammad bin Yasin. My matric number is 221021303 from UR 65523002. For the introduction slide, maritime surveillance is extremely important because more than 80% of global trade is conducted in the sea routes. Traditional ship monitoring relies on manual observation of human-assisted systems, which are time-consuming and prone to error. With the ability of high-resolution satellite imagery, automated ship detection using image processing has become a practical and efficient solution. In this project, we use histogram of orientation gradient (HOG) to extract structure features from the sheet image and support vector machine (SVM) for the classification. The goal is to reliably distinguish ship from sea background under different orientation and scale. For the objective, the main objective of the project is to compare three HOG variants: rectangular HOG, circular HOG, and pyramid HOG, to determine which geometry perform best of the sheet detection under non-biased training, meaning no rotation or argumentation is applied to the datasets. For the problem statement, there are three main challenges in automated maritime ship detection. First is rotation. Various ship can appear at any orientation, horizontal, vertical, or diagonal, causing standard descriptor to lose accuracy. Second is scale diversity. Ship vary significant in size from small fishing boat to a large cargo vessel, make detection difficult using a fixed window size. Third is environment noise, also known as a sea clutter, with sun glints and dark structure often resembling ship feature leading to false detection. This challenge motivate the need for more robust feature extraction and technique. Now we go to the project scope. The scope of the project is clearly defined. We focus on SOG-based feature extraction combined with FVN classification. Detection used is the in satellite imagery dataset from Kaggle consisting of 80 multiplied 80 RGB image. The project used optical satellite image only, excluding SAR or thermal image. All processing is done in a Python environment using offline image analysis.
So for the methodology, we are using two pipeline, which is training pipeline and what we call detection pipeline. So means we have two scripts. So for this training pipeline, we actually insert a data set that have 2,608 image that can be categorized into sheet and no sheet. Meaning have a sheet as a 1 and no sheet as a 0. And then at the same time, after that we are doing a what we call feature HOG descriptor, where first we do a what we call color normalization. We can say turn the color image into a grayscale, and also do a what we call image resize, what we call image normalization. Image resize mean we resize the scale into a normalized one, which is 64 to 64, the scale image. Yep. And then after we do computing the gradient, do a normalized block normalization to get its final picture vector, so that the computer can understand what the image looks like. So after we done getting the final feature vector, we can fit into the classifier. We are using SVM to do a prediction. So this technique, actually we are using three what I call variants HOG. So this pipeline we can choose whether we want to using the R HOG, main rectangular HOG, or what I call circular HOG, or the other one is P-HOG. I mean pyramid HOG. Um, yeah, in the script we can select using a selection case. Yeah, coding. So let's say if we choosing a R-HOG, and then it do as exact as I said, from dataset do a grayscale, resize, and last one get the training one, and then it do provide a pickle file, yeah, for the R-HOG, and it save it to be used um, in the other training pipeline. I mean not training, for the detection pipeline, or we can say it phase 2. Same also we want to choose for main what you call change, want to do a C-HOG, we can do by changing the script or the pipeline. The difference between RCP, actually R for the rectangular grid, each rectangular we call it pixel and it has a value in it. But for C, I can say it's like a circle, polar, or so. But for the PHOG, like it can scale in variation, means flexible to identify a varying size object. Like we can say it as a three plane, but each plane have a different dimension, so it can scale. It cannot scale, so it goes to another level. So we have 0, 1, 2 level of scaling.